Safety and cybersecurity. What companies need to consider for hydrogen plants. This episode is about how to ensure the functional safety and digital safety of hydrogen plants. Someone who deals with this topic very intensively on a daily basis is Philipp Glaser.
Get ready for Hydrogen, a Siemens podcast with Michael Pretorius and Philipp Glaser.
There is functional safety and there is digital safety. Let's try to bring both together a bit. One is the topic of safety in English, the other is the topic of cybersecurity in English. Enlighten me. How do we start? How do we structure the whole thing?
So for someone who is very much into process automation, I would say, let's start with the topic of functional plant safety when it comes to hydrogen. It is primarily about ensuring that the plant operates in a safe state, that it cannot create a dangerous situation, that nothing can explode in the worst case scenario, and that the plant can also shut down safely in an emergency. This means that functional safety is primarily the protection of people and machines in the facility. The second part is the topic of security, cybersecurity, which is about ensuring that no unauthorized person can access the plant, especially a plant that has a certain connectivity to the outside, perhaps because it is operated remotely, or because I might be doing things like remote maintenance, or want to use certain connectivity in my plant. In such cases, cybersecurity is, of course, a very important point. Many hydrogen plants, depending on their setup and application, will ultimately be considered part of critical infrastructure. This places particularly high demands on the topic of cybersecurity.
Now, these two topics can no longer really be separated from each other. I'll give an example. When we talk about predictive maintenance, that is, the proactive maintenance of components, which must also be redundant, for instance, to ensure that no operational factors fail, then it is really great if these components also be digitally monitored in this digital twin, requiring connectivity, meaning they must be connected to a digital system. Is it a greater challenge to combine such a digital twin with secure process technology? Or does it even make things easier?
No, as you say, we use the topic of digital hydrogen plants. The digital hydrogen plant naturally includes the concepts. For both, yes. So if I want to engage in remote operation and remote maintenance, then I obviously need both things. And we have naturally taken both things into account in our templates and blueprints on the topic of digital hydrogen plants. I would just like to give you an example if we briefly touch on the topic of security. What is special is that at Siemens we have a completely unique portfolio for the topic of network technology and also for the topic of cybersecurity. This is called the security in-depth concept with us, and we are leading and setting the tone in many areas, even when it comes to relevant standards and regulations, so that we are certainly the market leader for process industry plants or main automation plants when it comes to which communication components are used. And that is relatively important. When you are in a private setting or in an email environment, if you want to open an email and it takes a bit longer because the certificate still needs to be loaded, it's not a problem for you because the 5 seconds you wait don't cause any issue for you. But when I am in an industrial environment, I naturally also need certificates because it is of course very, very relevant that I have secure communication. However, it should not be the case that I have to wait somewhere for a certificate to load. And for that very reason, as the market leader and one of the main providers in automation, we have said it is important to have our own expertise, our own products, and our own portfolio for the topic of networking technology and cybersecurity, which is used in our plants worldwide, for example, from an automotive plant to the process engineering industry.
I would like to break down this digital hydrogen plant into its individual components a bit more, so we can see where the safety components and where the security components are installed. Let's just work on something quite typical, like the electrolyzer and the membrane. Perhaps you can say a little about the topic of safety components, as this is a crucial point where an explosion cannot occur, and where cybersecurity and digital safety play a role.
So if we now take a look at the electrolyzer, we are initially dealing with the process engineering unit. And when I look at the process engineering unit, we are initially in the area of functional plant safety. In other words, the plant must operate safely, and the protection of the machinery and the people inside or around the plant must be ensured. How does it work? It works by essentially starting with a comprehensive and detailed risk analysis for such a plant, a risk analysis or hazard analysis, which we also offer. We have in-house specialists for functional plant safety, who also have the relevant TÜV certifications, capable of conducting such risk analyses. And that's where it starts. You look at the plant, you examine how large the capacity is, how much hydrogen is in there, and how the plant is structured. But for example, also very important is whether it is enclosed, whether it is outside, and exactly where it is located. And that is really exciting when you look at it. In risk assessment, you might potentially have 2 different risk assessments for the same plant, depending on where it is located. Because, for example, one criterion in the assessment: is the facility located in a place where many people are constantly present? Is it in the city or in an industrial area where there are many people? Or is it located somewhere out in the green, wide field where rarely anyone passes by? Then you might in fact have an entirely and thoroughly different risk assessment for the same plant twice. It is exciting that we are currently seeing that we are, of course, dealing with various companies, some of which are startups or come from completely different industries, perhaps from wind energy or mechanical engineering, that do not have decades of experience in this whole field, and where you see, oh well, we don't really need something like safety because it's outside anyway, or things like that, where you see, oh, obviously, the authorities, I can only say from our own personal experiences in recent months, are already very cautious when it comes to the topic of safety. In the past, there may have been gaps where local authorities were perhaps not very sensitive. Perhaps right at the beginning with the topic of biogas, I think there is a very prominent example that only later came much more into the focus of the authorities regarding how dangerous it actually is when it comes to the issuance of operating permits. With hydrogen, we see that hydrogen is perhaps something that everyone already knows from school, television, or starting with the Hindenburg, and has in mind that, oh, hydrogen is not without danger. And it seems that the authorities are indeed very critical before they grant an operating license, and there are indeed some who now feel, oh, perhaps we should have paid a bit more attention to the topic earlier, and we can certainly do that now. And we are happy to support the industry and the customers because, on one hand, we have this knowledge on how to make a plant safe. What are the guidelines that apply there? How is a risk assessment to be conducted? But also, are systems up to automation? Of course, these requirements for functional safety can also be implemented so that the plant is truly safe.
There are quite a lot of sensors in there and all sorts of things that are constantly monitored. I'll stay briefly with this example of the electrolyzer and the membrane. So, it ultimately separates the oxygen from the hydrogen. I hope I said that correctly. Between the two of us, you are the one who is more into chemistry. Exactly. Hydrogen and oxygen. Exactly. And if there's a hole in the membrane, then it goes boom, and that's not cool at all. But of course, your sensors in these plants already know a great deal and understand what is happening in real time. And of course, with this topic of predictive maintenance, you have the opportunity to look into a plant earlier to see when which components, I would say wear parts, when should they be replaced early, namely before they break or depending on if they have already broken. That means these are the safety components you talked about, and ultimately they can no longer be separated from the digital aspects.
Absolutely. We don't want to bore the audience by mentioning the term hydrogen performance feed again, which we have already discussed in several episodes. The hydrogen performance feed can do exactly that. We have the topic of anomaly detection in there, but also because you just mentioned the topic of sensor technology. I can measure all sorts of things with sensors, but I cannot, for example, directly measure something like the degradation of a membrane. For this, I need to interpret measurement values. And that's exactly what we do in the hydrogen performance suite, because we compare the actual values we measure in the plant with the values we have in the simulation model, interpret the deviations, and can infer, for example, the degradation of the membrane. In other words, that means we say we can effectively measure the degradation of the membrane, essentially the process of doing so. This is called soft sensing, which are the values that we then store in the hydrogen performance suite, for example, with purple or with pink. This is marked. These are soft sensing values, which are precisely calculated values to capture such important things. And I would like to address an important point now, because we repeatedly see, especially in the hydrogen industry, that a hydrogen plant is composed of different parts. The so-called package units, which come in through different package unit suppliers. A special role is naturally played by the electrolyzer as the component where hydrogen is produced, and it is also a relatively complex component that must handle numbering up, where many similar ones are present. But now, at first glance, one might say it's like a machine, we're assembling machines there, but great caution is advised at this point, because the electrolyzer is a flawless process industry component. This means that the corresponding standards, such as IEC 615 or 11, must be followed to ensure the topic of safety, functional plant safety. To make a very brief digression about a machine, it is always the case that the safe state of the system is usually when it is off. I turn it off, then I am safe. In the process industry, this is not the case, because in the process industry, turning something off can be very dangerous. Instead, I need to bring the system to a safe state. I often like to compare this to driving or flying. When driving safely, you usually brake and come to a stop. In an airplane, braking is a bad idea. Instead, you need to land safely. And it's the same here. This means we need shutdown procedures, also known as ESD, emergency shutdown procedures, for example. And we have the same issue with the electrolyzer. For example, we cannot shut down the electrolyzer abruptly. This leads to various problems, up to the point where if I were to simply remove the voltage, remove the current, then the electrolyzer might possibly reverse, and it acts with the residual hydrogen present as a fuel cell. And that is, of course, a situation that can be extremely dangerous. That means, furthermore, in the hydrogen plant, we have connections and interactions between the various components and under the electrolyzer, but also, for example, between the electrolyzer and the compressors, which need to be considered when I have to bring the plant to a safe state. And these procedures must be correspondingly completely safe and must also be thoroughly traceable in the validation by TÜV. This must be transparent, must be verifiable, and must meet the requirements accordingly.
Now, this is something you can wonderfully simulate in the simulation and construction of such a digital hydrogen plant, or in the construction of the digital twin. That was it earlier. Templates were mentioned, meaning templates that you can ultimately click together on your computer during the engineering process. I imagine it a bit like a document template for a resume in Word. So correct me if I'm completely wrong, but that's how it's prepared.
Exactly. Yes, absolutely. And in this case, we are naturally also involved in the simulation of automation, for example with Simit, where you can simulate the different value combinations that occur accordingly. And now there is one thing I want to mention, which is the so-called safety matrix. The safety matrix is a tool in DCS system in SIMATIC PCS7, and it is really very simple, so actually any child can indeed easily handle it, even effortlessly. In one dimension, I have the causes, and in the other, I have the effects. This means that if this happens, then the reaction must be such and such. The emergency shutdown is not as complex as control system, because in control engineering we have control technology and automation technology, very complex things that need to happen to produce the right product in the right quality. In the emergency shutdown system, it is much more primitive because it is about bringing the plant to a safe state. I have to open some valves, maybe shut down some cooling circuits, some compressors, and influence similar things. But these functions, although they are more primitive, must be safe and operate securely. And that's why the safety matrix significantly reduces the functionality of the automation. That means I don't have to program procedurally. If this, then that must happen. And this value and every value. A complex and intricate mass of programming code is developed over time that, ultimately, in the end, no one can understand or review. What happens if I make an update or upgrade somewhere in the plant? Theoretically, I have to revalidate everything again. The safety matrix ensures that the requirements seen by the process engineer regarding emergency shutdowns and what actually needs to happen and how it is implemented in automation can be understood by all parties involved. Children can understand it, the automation engineer can understand it, the process engineer can understand it, and even a TÜV engineer can understand it. And even if I make changes to it 5 years later, and the automation engineer has long since moved on in their career, everyone can understand and everyone knows the plant is safe.
Because you just said everyone can understand it, you let me take a look at this engineering process, and the interesting thing was that it was ultimately nothing more than just a website, an HTML interface where you can click things together. This means that even in the engineering and design process, you can bring in people from outside, such as experts, to take a look. In the entire simulation process, you can also bring in external experts who can take a look at the plant. And you also mentioned in another episode that there are entirely new collaborations arise between different market participants, some of whom handle fleet management, while others may be the owner-operators of such a facility. This means that such networked collaboration is also possible here. However, I believe it becomes challenging when you also want certification to ensure that the plant is secure in terms of cybersecurity. Because there are also new directives in the EU. There is a new directive, this is the NIS2 directive, which states that companies here must meet higher safety requirements. There is much stronger enforcement. There are also sanctions for companies that do not comply. And the whole thing is also intended to improve collaboration between the member states regarding these EU member states concerning cybersecurity topics. This is also a topic that you have already incorporated into the entire template process and into this risk assessment.
Absolutely. Indeed, we have also created corresponding blueprints and templates here that specifically cover the topic of cybersecurity. I have already mentioned that we have our own portfolio, our own products, where we can also ensure the requirements of automation, plus the requirements of the entire network topic, network communication, including both availability and the topic of, for example, secure access, but also the whole topic of network security, ensuring that it is appropriately considered. In this respect, customers who build the plant with us holistically can totally relax because they get everything from a single source and it is tested. This is what we, with our specialists, can ensure is correctly implemented in the plant.
That also means perhaps interpreted the other way around. Correct me if I'm wrong. The components' performance, such as predictive maintenance, digital twin, the automation of process engineering, the whole topic of safety, and also the topic of cybersecurity makes sense when kept within an ecosystem.
Absolutely, that is our message. That's why we approached it so comprehensively, so holistically, the topic, that we wanted to implement a holistic concept for a digital hydrogen plant, our digital hydrogen plant, in such a way that all these elements come together. And especially in this industry, which is newly forming, with innovative plants where different players come together. You just mentioned these different players. If I now again, the hydrogen plants consists of different plant components and various package units that need to be integrated. Then each individual plant component must integrate optimally into the system. And of course, there are different interests, as we have discussed before. One person wants to be very flexible and optimize a single module. Another needs the simplest possible integration. A third needs the appropriate data to be able to maintain it, while another wants to protect their intellectual property. These are all things that need to be carefully considered, where corresponding and also different plant designs are required to accommodate them, and thoroughly. Nevertheless, the topic of safety must function holistically throughout the plant. It is not enough to make each individual part of the plant safe. There are additional requirements which apply to the entire plant, and this is true for both the topic of safety and the topic of security. For example, when different suppliers of various plant components might even want to continue monitoring their part of the plant. But with this, we can of course also provide them with new opportunities to enable their end customers to access corresponding services in this area. However, this is done in a secure manner.
So it's worth diving deeper into this topic, and if you're interested, then subscribe to this podcast or listen to the other episodes. Thank you, Philip.
This podcast was done by humans but localized with the help of AI. Thanks for listening.